Hi. Oh, nice. Cool. Hi, everyone. Today I'm going to talk to you about ZK-rollups. I'm going to try to stay on a relatively high level. And thanks, Northrop, for introducing part of what we do. I may repeat some stuff, but like a lot of complex topics, it's always good to hear it explained by different people. That way you'll get a clearer image in your mind. Before we start, can we make a quick show of hand? Who here ever made a transaction on Ethereum? That's not a stupid question. Who here is a dev? Cool. And who here, for example, is familiar with what you can do with a hash function? Right? Okay, cool. Just gauging, thank you. Okay, so today I'm going to explain to you how ZK rollups work and what you can do with them that makes them exciting. So before starting, let's talk about what validity proofs are. So you may have heard the term ZK rollup. We don't really like that term because, like a lot of terms in the crypto industry, it's very badly defined. It doesn't mean much, and specifically our rollups are not ZK. I'm not going to get into details, but basically know that when I say validity proofs or validity rollup, what most people would say is ZK rollup, right? They're more or less interchangeable. We're trying to use more validity rollups, though. So let's start with the first question. Why do blockchains suck? I mean, think about it. Bitcoin has been here for like, what, 10, 15 years? Ethereum for a bit less than 10 years. In the same span of time they've been around, massive payment systems have scaled to millions of transactions. Think about Alipay. How big is that? How come this is faster when it's using an older technology? Why doesn't it scale? Why doesn't the blockchain scale? Well, it all boils down to the model of trust you use in these networks. In your banking network or your Alipay network, you will rely on a single trusted party that will maintain a ledger or a state, so basically the list of who owns what for everybody. So they do that for everybody. So you have one person maintaining the state. This is what we call delegated accountability. You don't get a say into how the balances are maintained. You know somebody is doing it, so you're delegating that responsibility to somebody else. It has nice benefits, but of course, blockchains are more interesting. I'm not going to get into why they're more interesting, but one of the way they work is that they have inclusive accountability, meaning that everybody is in charge of maintaining the same state of the network. And here you have your first heuristic as to why these networks are expensive. When an amount of work is done by one person, or when it is done by everyone, obviously it's going to be more expensive if more people do it. You have to pay people to do the same amount of work. It's kind of if we were all going to a restaurant and we all order some food, and at the end of the night, we all want to pay our specific share of the bill, right? And we all agree on who should pay what. Like, we agree on the rules of the system. In the traditional world, we would have NorSwap do all the account for everybody and say, you own that much, you own that much. And you trust him. You trust him that he did it correctly. You trust him that he didn't put any money in his pocket and things like that. In the blockchain world, we all take all the receipt and we all recompute all the balances of everyone. That's obviously way more work, but it gives you nice property. You don't need to trust anybody. You know that the calculations were made correctly. Now, the question becomes, how do you scale blockchains? How do you make it bigger while keeping inclusive accountability, right? So how, taking back the example I just took with the restaurant, if there's 5 of us, you might be able to do it. If there's 500 of us, it's a bit more difficult, right? There's a lot more information in the system. The question becomes, how do you do that without needing to trust somebody? And here, I want to introduce a small, like, a little brick that you can put in your brain, in your toolkit for blockchains, just like hashing functions or just like signature algorithm. You know what you can do with a hash function or a signature algorithm, right? A hash function is a digital fingerprint for an amount of data, right? You know that underneath it's mathematics. You can go dig in if you want to, but you don't really need to dig into that to know how to use it. Well, validity proofs or Stark proofs, think of them that way. They're a way for a party, let's call her Alice, to write a program and execute it. And it's a very big program that she executes on a very big computer, right? Or a small one, doesn't matter, but in my example, it's a big computer. And she wants Bob to know that the result of the execution of that program is a specific value. Now, Alice, the only solution Alice had up until now was to say, Bob, okay, run the program. So Bob needs a very big computer, which doesn't really work because he doesn't have one. So now Alice can use a validity proof, so she will run the program and generate for that program a proof of execution, which is just a cryptographical value that Bob can verify. And Bob has mathematical certainty that this specific program yielded that result. That's what validity proofs are in a nutshell. They're a way for a party to prove to another party that some computation was done correctly without the other party having to do that actual computation. And like Narswap mentioned, what's really cool is that it's much, much easier to verify the proof than it is to execute the program, right? So now, you have this dynamic with what we call a prover, so somebody executing the program and generating the proof, and a verifier, the person who just received the receipt and verify that the program was executed correctly. How do we use that in a blockchain network? Well, basically, we wrote an L2, so a blockchain network, that when it moves from block 0 to block 100, it generates a proof that it did so correctly. And anybody can verify that this specific transition from block 0 to block 100 was done correctly, that nobody cheated, without having to actually compute all the blocks from 0 to 100. Which is pretty cool because, again, it allows people with small resources to validate trustlessly that something done on a very big computer was done correctly. And the really cool stuff with that is that it's not just a machine. Ethereum itself is able to verify these proofs. You can write a smart contract that verifies these proofs. To the best of my knowledge, that's the only context where a blockchain is able to know that something else happened outside of it without trusting a human in the middle. Okay, any question? Probably later, right? Cool. Okay, so just mention something else here. What's really cool with this is that for the first time, you're able to delegate computation outside of the network. You don't have to have everybody do the same computation. You can have some actors specialize, and the others inside the network use these results without having to execute the same computation. So it allows delegating execution to the edges of the network. So now, in a nutshell, who are we, right? I work for a company called Starkware. So Starkware is a team of 80 people, more or less. We've been here for about 4 years. Our founders were the inventors of the Stark protocol, which is basically a way to prove computation, like I explained. And we focus on scalability for blockchains. In our quest for that, the first thing we did was write a programming language that is provable, meaning you can write any kind of program. It's not a smart contract language. It's a general purpose programming language. And then generate a proof that you executed that correctly. With that, the first thing we thought was, okay, so how do we use this to scale the blockchain? Well, the first thing people were really into at some point was exchanges. So exchanging ERC20s, exchanging NFTs. And so we came up with StarkX. StarkX is a white label trading engine that allows you to do spots and perpetual, and that runs on top of Ethereum. I'm going to go into it in a sec, into statistics. And this was a massive success. And after that, we thought, you know, trading is fine, trading is fun, but you can do way more stuff with a blockchain and with smart contracts. So why not try to do more? And so we came up with StarkNet, which is a general purpose smart contract platform running on top of Ethereum that is also provable. Okay, and I'm gonna get into StarkNet's roadmap in a sec. Let's go to StarkX first. Let's try to digest, because a lot of time people say, oh yes, L2 are the future of Ethereum. They're not, they're its present. They're very much its present. StarkX, to date, I updated this not so long ago, did in total cumulative trading of $600 billion with a B. That's huge, that's an amazing number. And in the fun fact, the week in which StarkX crossed $500 billion in cumulative trading value, that same week, there were more transactions on StarkX than on Ethereum, on the underlying network. And nobody noticed, because that's how efficient it is. Because they were able to coalesce all these transactions into a few proofs that didn't impact the network that much. So you already have a network that scales Ethereum in a crazy way, that allows to do a lot more stuff in a trustless manner. We mint a shit ton of NFTs. We have very high-profile projects using StarkX, such as Sorare. Who here has ever heard about Sorare? Yeah, right? Nobody from Sorare in the room? Okay. There we have also Immutable using these. And aside from just these raw numbers, which are impressive in and of themselves, I want to talk about the efficiency gains. DYDX, who is a trading exchange, right? They've been able to reduce the cost of transaction between 500 to 1,000, which is a huge improvement in ZK-rollup mode. I'm not going to get too much into it, but in the most secure mode StarkX allows. Sorare Immutable made a slightly different security choice, meaning that they make a different security assumption, and they've been able to reduce the cost of minting NFTs by 20,000. It's hard to wrap your head around how much that is. What I want to give you as an idea is that they've been able to do something that all blockchain companies fantasize on doing, meaning that they've been able to abstract away network fees. You have a user-facing app. What's the worst thing you can do? What's the worst thing with user experience today? You need ETH to pay for gas and stuff like that. So you need to pay the network. They've been able to abstract that away so that people just use the app and don't have to care about gas. How cool is that? Anyways, that's StarkX. Moving on to StarkNet. So it's still in alpha, so it's a network that you can use. Since 2 weeks ago, we are at feature parity with Ethereum, meaning anything you can do on Ethereum, you can do on StarkNet. Right now, we're focusing on throughput. We want the network to be blazingly fast, and we should have strong improvements by the end of this year. And then we want to work on decentralization, meaning that right now, the network is operated by us, right? It's no small feat to have this kind of mathematical process running in the background, so we're operating it. But we don't have an interest in running a private permission network. We're very much building a decentralized open network. And we want to have a very clear roadmap and vision as to where we're going with that by the end of the year, and probably next year implement it, okay? So that's where we are with StarkNet. Now, I still have 5 minutes, right? I want to talk a bit about what you can do with that, because most people, when you think about L2s, people think about, oh, cheap transactions, which is cool. I love cheap transactions, and there's this fun fact on ZK-rollup that, you know, on most blockchain networks, the more transaction, the higher the cost per transaction, right? On ZK-rollups, technically, the cost of verifying scales logarithmically with the workload that you're proving, which means that the more transaction, the cheaper per transaction it gets. How crazy is that? Like, the more the network is congested, the cheaper transactions get. Weird, right? We're going to find out how that works in the next few years, but that's fun. But cheap transactions are good, but when you think about having more processing power, you can do more of the same, or you can do new things. You can do more complex calculation. I kind of like saying Ethereum is like a bread toaster. You can toast bread, it's nice. You can have maybe 2 at a time, 4 at a time, that's great. Starknet is like a oven. You can put sheets with a lot of bread to toast a lot of bread at the same time, or you can make cake, or you can make a chicken or pottery, right? It's just a new design that allows you to do fundamentally different stuff that you could do before. And that's what is exciting to a lot of people with ZK-rollup. They basically give smart contract developer more processing power, more computing power to use in their applications. And there's a myriad of stuff you could do with that. I can't tell you what exactly will emerge as the use case because we're exploring that frontier. If that's something that sounds interesting to you, come talk. For sure, I'll point you in the right direction to explore that. Basically, it gives more power to application developer. Another really interesting properties is that this is trustless in the sense that you don't rely on game theory. You don't rely on trusting a human. You rely on core mathematical function. This makes it possible to have fully trustless bridges. I'm not going to get too much into that, but basically it allows you having an L2 where you don't just clone your L2 and have a second instantiation of your system on another layer. An application where you basically extend what you do on L1 on L2. So, better. So it allows you to build really cross-layer applications where you can have, for example, applications where you have the liquidity, the muscles, sitting on L1 and the brain sitting on L2. Snapshot is building something like that, so go talk with them if you're interested. So you really get to build a rich cross-layer application. The first thing I want to mention is what we call recursion, which is basically, okay, so when you're running Starknet, you're proving that you did something to Ethereum. What if, hear me out, you could run something on top of Starknet and prove that to Starknet? Then all of a sudden, you get a network with a network on top of it trustlessly, and this can go how high as you want. You can get your own app-specific chain in a trustless manner. You can give massive scalability. Like, you can go in a lot of directions with that. You can get private transactions where you generate a proof on your cell phone. And that's a very interesting and active area of research. So that's something people get excited about also. Yeah, that's the end of my presentation. I could have spent 15 minutes on each of those slides. Happy to take questions if there are. Happy to talk with you if you have questions afterward. If you're a dev and you want to explore what you can do on Starknet, reach out. We're nice. We're doing a meetup tonight, not so far away from here. We'll have Arjan with us and a Snapshot. And it's going to be fun. We're going to talk about our weird programming language, Cairo, which is not that difficult. You can talk to Scott. He will demystify it for you. And yeah, so join us. It's going to be fun.
Thanks a lot, Henri. That was very instructive and very exciting.